So in this video, I'm going to solve the problem leftmost column with at least 1. So to demonstrate what this problem is asking us to do, I'm going to show you 4 examples from LeetCode. So we're given a matrix and we have to find the leftmost column with has at least 1 in it. So in this example, the leftmost column with a 1 is the 0th column, and they're numbered like 0, 1, 2, 3. So our output would be 0. And in this example, the leftmost column with a 1 is 1. So the output would be 1. And in this example, there are no columns with a 1 in them. So the output would be -1. And in this example, the leftmost column with a 1 is 1. So the output would be 1. And just so you know that this matrix is also solid input. And we're given these 2 arguments to access the binary matrix. We can use the get function, which returns the element at this index xy. And we're also given the dimensions, which shows that the matrix is n by m. So the instructions for this problem are that for the constraints we have that we can have up to 100 rows and up to 100 columns. So we can check each and every row and each and every element of this matrix, because then we'd be checking it 100 times 100, which is 10,000 times in the if we in the case that we actually got 100 and columns and rows, and we're only allowed to check them the elements 1,000 times, so we can do that. And also another constraint is that every element is either a 0 or a 1. And the third constraint is that every column is sorted in a non-decreasing way. So what that means is that if for a certain column, if you know that a certain row has a 1, then every row to the right of it is 1. And if you know that a certain row in that column is a 0, then every row to the left of that 0 would be a 0. So this is the algorithm that I came up with in Python 3 to solve this this problem. And to explain this algorithm, I'm going to use an example. So initially, we don't know anything about the matrix, but I'm going to use this matrix as an example. So when we're accessing the matrix, so to begin with, let's set the row to 0 and the column to 3 to access it from the top right. And the output column is initially set to -1 because I don't know if I have any 1s in this matrix. So first I go ahead and check for the 0th row and the 3rd column whether it is 1. So indeed it is. So I set the output column to -1, because now I know that for now I know that the 3rd column has 1 in it. And after that, I check the row to the left of it in the same column whether that has a 1, and indeed it does. So I set the column to 2 now, because that's the leftmost column that I know has a 1. And then I check the column to the right of it, and it has a 0. So I don't change the output column for now. But then I check the column underneath that in case that has a 1. And it doesn't. That's also 0. So I don't change anything. And then I check the column to underneath that in case that has a 1, and indeed it does. So I change the output column to 1. And now I check the row to the right, to the left of that, and that's the 0s. And now I've reached the condition that I've reached the maximum row and the minimum column. So I've gone from the top right to the bottom left. So now I'm ending the while loop, and I'm returning the column number, which is 1. That's the leftmost column that I know of. So that is the problem, and these are a few atypical cases. I'm not going to go into detail, but like you can, if you see these columns, like if you see these atypical cases, then you would know why some matrices, some algorithms that go into more detail don't work for these matrices, but uh, the algorithm that I set up here does work for these matrices. Thank you.